Hi, Mr. Richards here, and today's pre-algebra lesson is on functions. First, we have some vocabulary to get us started on functions, independent variables, dependent variables. And a function is a relation in which each element of the domain is paired with exactly one element of the range. Now, the independent variable, how can we describe that? Well, the domain is going to contain all values of the independent. These values are chosen, and these values do not depend on other variables. Contrast that with dependent variables. Well, the domain has all the independent, so the range contains all values of the dependent variable, and the values do depend on the values in the domain. So the dependent variables depend on what the independent variables are. Now, if we look actually at functions now, what is a function versus something that is not a function? Well, to start with our function, if I have my domain and my range, and I say, well, for my domain values, I'm going to have 3, 5, and 8. Where those numbers come from, I made them up. We can choose the values for the domain. Now, typically what you'll have with the function is some sort of rule. Multiply by 2, subtract 1, something along those lines, typically. Now, what if I say, okay, for my range, I'm going to have the values 2, 4, and 7. Well, you might be able to recognize that our rule here was just subtracting 1, but you'll be able to tell that the 3 and the 2 match, the 5 and the 4 match, and the 8 and the 7 match. Each domain has exactly one element in the range. That's a function. Now compare that to something that's not a function. I can still have a domain and a range. And if I pick for my domain values this time 2, 4, and 7, well, what if my elements of the range here are 1, 3, 6, and 5? And I pair up the 2 with the 1, the 4 with the 3, and the 7 with the 6 and the 5? Well, that's not a function because the domain does not have exactly 1 in the range. Here there's 1, here there's 1, but here there's 2. You can't have that. Each domain must have exactly one element of the range. So when we go to determine whether each relation is a function and explain, well, we can look, does each element in the domain have exactly one element in the range? Well, if we look at our domain values here, our domains are going to be our x's. So we have 3, 7, 5, 1, and 2. And those are matched up in our range. The 3 matches with the 48. The 7 matches with the 21. The 5 matches with the 15. The 1 matches with the 13. And the 2 matches with the 12. And so for this, yes, this is a function. Since each x value is paired with only one y value. Now contrast that here to B, where we have the domains being 8, 3, 10, we have 3 again, 2, and 5. And so our range, the 8 matches with the 12, the 3 matches with a 5, the 10 matches with an 8, and the 3 matches with the 12. The 2 matches with the 9, and the 5 matches with the 4. Well, here, since this 3 is going with a 12 and a 5, it does not have exactly one domain per range. So our answer is no, because 3 is paired with 2 range values. Remember, for this to be a function, each element of the domain is paired with exactly one element in the range, not 2. Another way to help determine whether or not something is a function is to use what's called the vertical line test. Now, for the definition of a vertical line test, if any vertical line drawn on a graph of a relation passes through no more than one point on the graph for each value of x in the domain, then the relation is a function. So if I have a graph and I have a relation graphed here, random points, then if I look at a vertical line, if I drag this vertical line across the graph, and you could always use a pencil, do I only come across one value at a time? So far, yes. Each x value only has one y value. So that does pass the vertical line test. Compare that now to a different type of graph, where you might have some other random points. And we use that same line now. I bring that down here, and I use the vertical line test. That's okay there. That's okay there. That's okay there. Still okay. Here we have 2 points on that vertical line. And since we have 2 points on the vertical line, the second one is not a function, while the first one was a function. Now, determine whether the graph below is a function and explain our answer. Well, let's bring in a new line right there. And let's use the vertical line test. And again, you can use a pencil as you drag across. This point's okay. This point's okay. This point's okay. Still okay. But here we are not. We have 2 points that go through the vertical line. So when we go to write our answer, we can write no, the vertical line test shows that it passes through 2 points on the graph with the same x value. And again, remember, you can only have one x per y. What this vertical line test shows is that for right here and here, your x was 7, and you had y's at 2 and 5. Well, you have a domain value of 7 that goes to 2 different range values. So the vertical line test is a great graphical way of organizing our functions and determining whether or not a relation is a function. Now, the second half of this lesson deals with function rules and finding function values and function notation. So let's first define what a function rule is. A function rule describes the operations performed on the domain, and our domain is usually our x's, which is going to be our input. So it describes operations performed on the domain, which is our input, to get the range, which will be our output, and can be used to write an equation that relates the variables. And when it comes to equations versus function notation is simply defined as a function written as an equation. And there is a way of doing this. An equation, well, that would be something like y equals 2x plus 3. In function notation, this would be the function of x equals 2x plus 3. It's saying y is a function of x. So x is our domain, and that cranks out into the function the output of y, or f of x, since our output is our range. And if you go back and think, where our domain is independent, I can put anything I want in for x, and this function f of x, which has typically been known as our y, that will depend on what you put on the input. So it helps define our input and our output and our independent and dependent variables. Now, when it gets down to our examples here, if f of x equals x plus 5, find each function value. Well, for f of 7, we can say, well, if we have f of 7, we're going to say 6 times 7 plus 5. We substitute in the 7 for x. Means that's going to equal 42 plus 5, which is 47. And for f of negative 4, if we put in negative 4 for x, we have 6 times negative 4 plus 5. Well, 6 times negative 4 is negative 24, plus 5 is negative 19. So we get outputs of 47 and negative 19. And of course, those were dependent on what we put into the function. Now, our word problem uses function notation. Miss Newman spent $8.82 buying postcards that sold for 49 cents each. Part 1, Part A, identify the independent and dependent variables. Then write a function to represent the total cost of any postcards. Well, when we think about dependent versus independent here, we'll think about our dependent and our independent. The dependent depends on what the independent is. So what matters to what? Well, I think here that our total cost is going to depend on the number of postcards you buy. It's certainly not going to be the other way around. So the total cost is our dependent variable, and we're going to say that's C, because that depends on the number of postcards we buy, and we can call that P. So for our function notation, the cost, which we could write as C, the cost of postcards, is going to equal the number of postcards you buy times 49 cents each. So times 49 cents per postcard. So our cost, the dependent variable, is going to equal the 49 cents times the number of postcards you buy. And we can use that function now, the cost equaling 49 cents per postcard, to determine the number of postcards purchased. Well, we're told that she spent $8.82, so that's actually our cost. $8.82 is going to equal 49 cents per postcard. And if we divide by 49 cents here on both sides, this cancels, and we get an answer of 18 equals P. So she bought 18 postcards at 49 cents each to be $8.82. That is it for this lesson on functions.